we are going to be doing the determination of citric acid in soda lab. This is a two-part experiment. The first part is a standardization procedure where we're going to figure out our concentration of sodium hydroxide. And then in part 2, we're going to use that molarity of sodium hydroxide to determine the concentration of citric acid in soda. So to begin, we have our titration apparatus with our burette here and our burette holder. This burette has already been cleaned. So the first few steps of the procedure talk about rinsing the burette with water and then filling it with sodium hydroxide to rinse it with sodium hydroxide. That part I will do. So I have my sodium hydroxide here. I'm going to have my waste beaker underneath. This is called a stopcock, and when it's upright like this, then this tip is open. If it's turned like perpendicular to the nozzle, it's closed, and that would stop the flow of my titrant out of the burette. So my sodium hydroxide, it's in a nice little squirt bottle, so I can squirt some in. And I'm letting that drain out into my waste beaker. Add some more. And what this is doing is it's flushing out whatever was inside the burette before and replacing it with our sodium hydroxide. All right, and I can see the tip is completely filled with sodium hydroxide. There is no air bubble at all. And so now I'm going to close the burette so that there's not an air bubble. And now that it's rinsed out with sodium hydroxide, I can fill it all the way up. I don't have to fill all the way to the zero. Anywhere near the top is good enough. So turn that so that I can see the lines. I'm going to hold this piece of paper behind there so that I can record my measurement. So make sure that that's 0 and that's a 1. So halfway in there, between there is 0.5, and then that would be like a line for 0.6 would be below that. So make sure you're reading from the bottom of the meniscus. The number you write down should be between 0 and 1. Okay. So now that I've recorded my initial volume of, so that number you write down will go into this initial volume of sodium hydroxide box. So next up, it says I have to obtain, let's see where, I have to add my mass of oxalic acid dihydrate to my Erlenmeyer flask. And so here's my Erlenmeyer flask. And so this is what I'm going to be weighing my oxalic acid into. So let's bring my Erlenmeyer flask with me to the balance, and then I'll be weighing some out on weighing paper. So here's my weighing paper, and these are dirty. I shouldn't use these. So I got my clean scapula, and I need to weigh out about 0.1 grams of oxalic acid. So I got to grab my oxalic acid here. And then cooperate. Thank you. About 0.1 to 0.125. So I'm within the target range now. And so the mass on my weighing paper is 0.1194 grams. So now that I have my oxalic acid, I will dump it into my Erlenmeyer flask and then put this back on the balance to make sure that I got all of it off. And so I want to write down that once I dumped it out, my weighing paper after adding the oxalic acid to my flask still says 0.0000. So that means I got all of it off onto here. This amount of oxalic acid that I weighed out extra, that will just be for my trial 2 later. So we'll come back over here. Okay, so here I am getting ready for my titration. I have my oxalic acid in my flask, and so the next part of the procedure says I have to add approximately 10 milliliters of deionized water. It doesn't actually matter how much water I add. So if I had a graduated cylinder, I would do that. But I think that's probably good. That's how you would use a graduated cylinder though. Okay, so I've swirled that to dissolve my oxalic acid. And so the next step says I have to add 2 to 3 drops of phenolphthalein. So here's my phenolphthalein. 1, 2, 3. Phenolphthalein. Okay, so set that off to the side. I'm working over a white towel so that once this changes color, I'll be able to see it. Sometimes it's really hard to see the endpoint against a black background. So I'm going to start adding my sodium hydroxide to my flask. I can add about 10 milliliters very quickly because I know the endpoints after that. But you wouldn't know that unless you've done this before. So I'm opening the stopcock and just letting it drain very quickly. You can see that it's pink right where it lands. Okay, so that was 10 milliliters very quickly. So I'm going to need to start swirling. And so this is sometimes like, rubbing your belly and patting your head at the same time. It's hard to do with the coordination of the two activities. So phenolphthalein kind of gives you a warning shot. So the longer you see that pink color last, the closer you are to the endpoint. So it's pink when it lands, but it goes away once I swirl. So I'm just getting closer. Turn this around. I'm right-handed, but I can swirl better with my left hand or right hand. Getting closer. Ooh. Okay, I'm not going to add any more until I can, oh darn, pink color went away. This is what we know as titration frustration syndrome, when you think you're done, but you're just really, really close. Sometimes I wish I was not left-handed. Okay, one drop. So we're looking for that light pink, persistent light pink color. And the more I swirl, the more I'm getting those last oxalic acid and sodium hydroxide ions to touch each other and react. And so I can see a persistent, very faint pink color. So we're going to call that good. Now I need to record my final volume of sodium hydroxide in my burette. Okay, so now hold a piece of paper behind there. And so remember that that line is 19 and that line is 20. And so the number you write down should be between 19 and 20. And the bottom of the meniscus is there. Make sure you're including your estimated digits. There are 10 lines in between the 20 and the 19. So you have to make sure you're getting an estimated digit in there. I'm not sure with the camera how much you'll be able to see. So we record that endpoint, and that is for part 1 of the experiment. And so now we're going to get started with part 2. Ordinarily we would do 3 trials, but for the sake of this video, we're only going to do 1 trial. And so we're going to move on to part 2 of the lab. So for part 2 of the lab, we're titrating our citric acid soda. And so we're still going to be using sodium hydroxide in this burette. And so I'm going to go ahead and fill this back up with sodium hydroxide. Making sure my stopcock is closed. Okay, so I filled this back up with sodium hydroxide. And so you can record your initial measurement of sodium hydroxide. And so the bottom of the meniscus is below the 0. So write down that measurement as your initial measurement for part 2. Okay. So flipping to the procedure for part 2. I need to get a small beaker of soda so that I don't contaminate other things. But here's my bottle of 6-ounce soda. 6-down soda is similar to a name brand, but by another well-known name. And I need to go get a beaker and a 10 milliliter transfer pipette. And through the magic of Lab Partners, I now have a beaker, with my 6-down soda and my 10 milliliter volumetric pipette. And we gotta remember our significant figures. That is not just 10 milliliters, because this is volumetric glassware, it's really 10.00 milliliters. So we're going to go ahead and get drawing the pipette. There's some water in there. Okay, so we're going to go up to the line. And I'm waiting, trying to get the bottom of the meniscus right on the line. Okay, so now I got the now I can dispense that 10 milliliters into this Erlenmeyer flask. And now we're ready to add our phenolphthalein indicator and titrate this. So again, I have to always add my phenolphthalein indicator, otherwise it won't change colors. So I added my 3 drops of phenolphthalein. All right, and I've already recorded my initial volume. And so again, I can add about 10 milliliters very quickly. That's the safe zone before I really have to be concerned about it changing colors. So I'm keeping an eye on it. So I've added about 10 milliliters. So now I'm in this part where I have to go a little bit more carefully. So I'm swirling, swirling, swirling. And I'm starting to see it pink when it lands. And so I'm going to slow down a bit so that I don't overshoot my endpoint. The pink color goes away when I swirl, so I wasn't there yet. I've seen lighter pink, but at least it's not fuchsia. After I record my final volume, I'll show you what fuchsia looks like. So it's not my best light pink, but it's still pretty light pink. I've seen better though. Swirl. Sometimes when you swirl, you can get it to lighten up a bit. All right, so I'm gonna have to record this volume. The final volume is, the numbers are right there where it's gonna make it hard to read because of the clamp holder. So I'm gonna move it up a little bit so I can read where the numbers are. And let me turn to a blank page in my lab manual. And hopefully you can see the measurements there. So the number you write down should be between 15 and 16. And remember, there's 10 lines in between the 15 and the 16. So hopefully you got a good view of that. So I believe normally we would do 3 trials, but for the sake of time here, we will not be doing 3 trials. So yeah. So you have recorded all the data you need to do all of this, calculating your molarity of 6 down. And then when you get down here to these additional calculations, make sure you read this sentence right here, because it tells you how to calculate your molarity of 7-Up in soda. Then you can use some dimensional analysis to calculate the grams of citric acid in 1 can of 7-Up, because we will know the molarity. We have the volume, we will know the molarity, and so that will help us figure out how many moles. And then you know how to go from moles to grams. So have fun with that. Anything else?
You gotta do the fuchsia, you said.
Oh yeah, I'd show them the fuchsia. So you have all the data you need, but this is what happens if you add too much. So if you add too much sodium hydroxide, you get a really pink color. So that's what fuchsia looks like. And so you can see what a much brighter pink color that is compared to our initial trial for part 1. So we're going for a very light pink color.